Today's lesson, we're going to be able to identify key features like x-intercepts, y-intercepts, local maximum, minimum, talk about increasing, decreasing intervals over our graphs, and also talk about interval notation for those pieces of our graphs. And typically we do this with functions. So a couple of things to review. What is an x-intercept and a y-intercept? Just like it sounds, an x-intercept is a point where the graph intersects the x-axis. So anytime it intersects the x-axis, that output would be 0. So we're going to look for a 0 in the output on a graph, on a table in the output part. The coordinates then, when we write the location, would always be parentheses because it's a point, a location, the number for the x value, the input, and always a 0 and an output. A y-intercept is a point where the graph intersects the y-axis. Okay, so we're going to look for an input is 0 because anything along the y-axis is an input of 0 and the number would be the output. So let's take a look at an example. Here we have a graph of our function f of x equals negative x to the third power plus 19x minus 30. What we want to do is identify any x-intercepts or y-intercepts that are up here on our graph and write their coordinates. So a couple things I would like you to do to think about that. One is, how is the graph behaving? So is this a function? Well, we're going to see, does every input have one output? Yes, we can see that. We also see the function notation there, so we know it's a function. Can you take your pencil, or just if you on the paper as well, put a plus where the function is increasing, a minus where the function is decreasing, and if the function is not changing, can you put a 0 or write constant? Do we match? So let's see. I said the first part was decreasing, right? Because the outputs are going down as the inputs are going up. Then it gets to this point here where it's going to turn, and look, as the inputs continue to increase, so do the outputs. And then it gets to this point here and it turns. As the inputs increase, the outputs decrease. So we're talking about the intervals of increasing and decreasing. We have 2 decreasing intervals on our graph and 1 increasing. Can you also take your pencil and now mark any places that you think you have any x-intercepts in one color and y-intercepts in another color? Here I have 3 x-intercepts because the output is 0. Can we write the locations of those x-intercepts? Well, because they are on the grid points of our graph, we can't. I'm going to read them off going from the left to right. Order is not important, just as long as you have the 3. So here my first one is at negative 5, 0. My second one is at 2, 0. And my third is at 3, 0. So 3 x-intercepts, 3 places where the graph crosses the x-axis, where the output is 0. Now, do we have any y-intercepts? We do. We have 1. Remember, the y-intercept is where the input is 0, and it's not falling directly on a grid point. So what we could do, if the input is 0 and we have a rule for the function, is put 0 into the function and see what we get out. So remember, we have the opposite of 0 to the third power. Well, 0 times 0 times 0 is 0. The opposite of 0 is 0. We're going to add that to 19 times 0. Well, that's 0. And then we're going to subtract 30. Well, 0 minus 30 is negative 30. So we have our y-intercept at 0, negative 30. So we can use a graph and look for those locations to find x-intercepts and y-intercepts, talking about increasing and decreasing intervals with our pluses and minuses. Let's take a look at a table of values and try to do the same thing. So can we use our table of values, our input and output table, to find any x-intercepts and y-intercepts? Let's give you a moment to think about that. Jot down your thoughts. Think about the definitions again of your x-intercept and your y-intercept. So when we're looking for an x-intercept, remember the output is 0. That's where it's crossing the x-axis. So the outputs in our table are the y's, and I want to see where there's a 0. And there's 1 here. So this point, negative 2, 0, represents an x-intercept. Our y-intercepts have inputs of 0 because it's crossing the y-axis. And look at my input table, or column I should say. See where the input of 0 is, if I have one, and I have my y-intercept, right? So here, my x-intercept is at negative 2, 0. My y-intercept is at 0, 5.7. Now, just like in the graph, we could talk about increasing and decreasing intervals or constant intervals. And I'm going to look to see how the input and output columns change. So my inputs, if I look, these are all increasing by 1. Okay, so if we're looking from the left to the right, they're all going up by 1. Now the y's, okay, so if we look, this decrease from 2.5 to 0, right? So we're decreasing from here to here. But then look, 0, 4.5, 5.7, 15, 17.8, we have an increasing interval from this point on. So here we're decreasing, then we start increasing. So we can use that part of the table to help us as well. So let's do some more practice with increasing and decreasing intervals. If we look at this graph here. So here we have our graph. Notice we have a scale for the inputs, no scale for the outputs, but that's not an issue because we're not looking to see about those values. We just want to identify if the graph is increasing or decreasing during the following intervals that are given. So what I would ask you to do now is, with your pencil, do a plus where you see that it's increasing on the graph, a minus where you see that it's decreasing. And if it's constant, you could put a 0 or write constant, that there's no change on the graph. I would also ask you, with your different colors, mark any x-intercepts or y-intercepts that you see. So let's check at the intervals. Do we agree with our increasing and decreasing? So here are the outputs, again, as we're going from left to right. So as the inputs are increasing, the outputs are going down till they get to this point here. Then they start going up. Then there's no change in output, so it's constant. Then the outputs start increasing to this point here, where they start decreasing till they get to this point here. Then they start increasing, then it becomes constant and will remain so, right? The arrow means it's going to continue on forever in this direction, that output being the same. I should have mentioned here that as we look to the left of the graph, it would still decrease, right? Because you'd still have your outputs up here still coming down. We also mentioned looking for intercepts because sometimes those are very helpful. By looking at the graph, I do see x-intercepts and I do see a y-intercept. In fact, I see 3 x-intercepts and 1 y-intercept. So now that we've got these key features for our graph marked, let's see if we can identify these intervals, again, as increasing and decreasing. And by marking up the picture, it helps it go along a lot quicker. So the intervals that we want to look at, if we look at part A, says we want to look at the interval where x is greater than negative 5 but less than negative 3. So x is referring to the inputs, right? So we're using these x values, the inputs, to see what's happening. So if I go and look at those inputs, right, we are going to think, okay, negative 5, here's our boundary here, to negative 3, here's our boundary here. So as I look for these inputs, what are the outputs doing? The outputs we said are increasing, so we can write increasing. Now intervals can be written as inequalities, but we also have another notation that we could use, and I wrote that below. Now, we have the negative 5 as our left bound, and we have the negative 3 as the right bound. Because they are not included, again, think going back to when we're graphing our inequalities on the number line. When they were less than or greater than, we were saying that those did not meet the requirements for that rule. They were excluded. So to show that in interval notation, we use parentheses when anytime we're excluding a value from our set. So these two are saying the same thing. It's saying, hey, look at the inputs from negative 5 to 3, but not negative 3, but not including them. And we know that this function is increasing. So the next interval we were asked to look at was when x is greater than -3 but less than -1. Okay, so here's our boundary, -3. Here's our other boundary, -1. Now, we are not including what's happening at -3 and -1. Those are excluded. So if I wanted to write it in the interval notation, I would have parentheses -3, comma, -1. Well, what's happening with the outputs for this function? They're not changing at all, right? We wrote 0. That means it's constant during that interval. The next interval we were asked to look at was from when x is greater than 1, so let me change that here, but less than 4. So let me change the other one. And again, we're not including the 1 and the 4, so if we wanted to write it in interval notation, we'd have parentheses 1, comma, 4. What are the outputs doing over this interval? Well, we said that they were decreasing. We had the minus sign there. And we had one more interval to look at. It was when x was less than, when 5 is less than x, so when x is greater than 5, but x is less than positive infinity. So we really don't have another bound, right? We're just looking to everything that's greater than 5. So we can see that there's no change, it's constant. Now, how are we going to write that interval? Well, we're not including the 5, and infinity doesn't stop, so we can't have something included for that. So we're still going to have parentheses. So anytime infinity, positive or negative, is being used, we need a parenthesis when we're talking about the interval notation. And again, it's constant. There was no change over that interval. All right, let's take a look at another function situation. Can you list the intervals where the graph increases, decreases, or is constant? And can you identify any x-intercepts or y-intercepts? So what I would have you do is mark up your picture, right? Put pluses where it's increasing, minuses where it's decreasing, a 0 or write constant where there's no change. Then with their different colors, can you mark any x-intercepts or y-intercepts that you see? All right, let's check what we've got so far. We can start reading our function from left to right, so we can see that there's a beginning to our function, right? We have a solid point. There's no change with the output, so that's, I put a 0 for constant. Then we get to this point here. Notice how it's changing. It starts increasing, and look, up, it's crossing the x-axis. You got an x-intercept. Still increasing till it gets to this point here, and look, it's crossing the y-axis, so we have a y-intercept. It turns to decrease till this point here. Hey, it's another x-intercept. And then it turns again and starts increasing, and will continue increasing going forward. All right, so let's talk about these key features about the x-intercepts and y-intercepts. We have 2 x-intercepts, we have 1 y-intercept. So what are the coordinates that we need? Our x-intercepts would be at -2, 0, and 2, 0. And our y-intercept is at 0, 2. So let's check the notation. And here's what our coordinates should look like, right? So we've got our x-intercepts at -2, 0, and 2, 0, and our y-intercept at 0, 2. We're also asked to list the intervals where they're increasing and decreasing and constant. So there's a couple of ways that we can do that. We can write them as an inequality, or we could also write them with our interval notation, meaning we use parentheses when something is excluded, and we would use a bracket when it is included. So we go back to our function picture here, talking about increasing intervals. So do we have any plus signs? And we have 2. So we want to think, well, from where to where is it increasing? So again, remember how I had my vertical lines as my boundaries? As I'm reading my graph from left to right, I can see that it started increasing from this point to this point, right? So let's think about, if we're talking about intervals, we're going to use the x values, the input values to talk about that. So that's looking from -4 to 0. The question is, are is -4 included in part of that rule or excluded? The same thing at 0. So we're going to look to see what happens at the points. Let me move these lines out of the way here so we can see what's going on. Well, -4 for the input. Look, we have an open point here. We learned before when it's open, it's not included, it's excluded. So we would have to use a parenthesis if we're going to use the interval notation. Now at 0, look at our point here, it was filled in, right? It's solid, so we'd have to have a bracket typically to do that if our function stopped here. It's not stopping here, right? It's turning to change. So we're going to use a parenthesis because it's not ending at that point, not like it ended here, right? So we're going to use a parenthesis from that point. So if we're going to interval notation, we're going to do left parenthesis, -4, comma 0, right parenthesis. Or if we want to write it as an inequality, we can say x is greater than -4, but less than 0. The other place that we saw it increasing was from 2, and then it continued on to infinity. So again, there's a turning point, right, from decreasing to increasing. So we're going to have to use a left parenthesis at 2, if we're going interval notation, comma, positive infinity, right parenthesis. We also could say that x is greater than 2, but less than positive infinity, or if you just wanted to write that x was greater than 2, that also would be fine. So where is our function decreasing? Well, we said that's happening here on our graph. So between 0 and 2. And again, look at the change of direction from increasing to decreasing. So we have our parentheses, right? Left parenthesis, 0, comma 2. We could also write that as x is greater than 0, but less than 2. Oops, let me move that over a little bit. We also had a section on our graph where we said that things were constant, right? So that was from -9 to -4. Now, -9, that's a definite beginning that's included, so we have to have a bracket around -9 if we're going to write it as interval notation, comma, and again, like we said with 4, that's open there, and it's also a change in intervals from constant to increasing, so we're going to use a parenthesis. That means if we're going to write it as an inequality, x is greater than or equal to -9, but less than -4. Again, let me scoot that over. So we can identify on a graph, writing our pluses, minuses, and zeros, if the intervals are increasing, decreasing, or staying constant. We can write them in interval notation with the parentheses or brackets, or as inequalities as well. So for these examples so far, we've been given the graphs and the tables to talk about the intervals, but could I ask you to make a graph based on the given information that has to happen over a certain interval? So if we look at this description here, it says sketch a graph with an x-intercept of 5, 0 and a y-intercept of 0, -7. So could you make a graph that meets those requirements? Well, since we have very particular points given to us, you have to have a scale on the graph so we know exactly where those locations are. And since those numbers are fairly small, we could probably use a scale of 1 to represent it. We also have 2 requirements where the x-intercept has to be at 5, 0, right? And the y-intercept has to be at 0, -7. Could you sketch a graph that uses both of those points? Sure. We can make many functions that would meet those requirements. One that comes to mind is I could draw an absolute value graph, right? So you may have seen this in the past, absolute values, right? Measures the distance from 0, takes on that V shape. It could be any type of function for the graph, one input for one output, as long as it's going through 0, -7, and 5, 0. So we have to have an increasing part of this interval here somehow, whether it looks straight or there's a curve. That part would have to be consistent on our graphs. But everything else, as long as you have one input, one output, you are good to go. Let's try another one. Here's your requirements. Could you sketch a graph with a y-intercept of 0, 2 that increases from the interval where x is greater than or equal to 0, but less than or equal to 5? Now, thinking about that interval, right, these points are included. So that's the inequality notation. I could write it in interval notation using my brackets. So it has to be increasing over the interval 0 to 5, and we need to have a y-intercept at 0, 2. Well, there's a couple of things we can do. Here's our interval 0 to 5. So someplace within this region, we have to have it going up. So you can make a sketch of your function doing just that. And remember, because it's stopping, right, starting and stopping, we want to have definite endpoints to our graph, whether it's straight, whether it's curved. That meets the requirement. Here's another scenario. We want to sketch a graph with an x-intercept of 3, 0 that increases from x is greater than 3 for that interval and decreases from the interval x is less than 3. So let's think about what that means. We have these two intervals in equality notation. You could write them in interval notation, right? Thinking about when x is greater than 3, right? All the values greater than 3. And where x is less than 3, decreasing. And it has to have an x-intercept of 3. So we're talking about our entire graph here, right? Because we have negative infinity to 3, so from here to here, this section, we have to have something decreasing. And 3 to positive infinity, from here to here, over this section, something has to be increasing. Can you make a sketch of a graph that meets those requirements? Sure. So it has to go through this point. Again, we said we needed something decreasing over this interval, which I do. And over this interval, I needed something increasing, which I do. Let's try one more. Sketch a graph with a y-intercept of 0, negative 7 that's going to decrease from the interval x is greater than or equal to negative 4 but less than 1 and is constant over the interval x is greater than 6. First thing I want to think about is I have to have a y-intercept of 0, negative 7. Then the next part is thinking about the two intervals given, one that's decreasing and constant. So what would that look like in interval notation? Well, this is included, right? And it would have to, since it's included, have an endpoint. This is excluded, or something's turning. And then this is greater than 6. So we want to think about something that's beginning here at 6 but not being used and continuing on in that direction. So this is how we would write those intervals in interval notation. Talking about how they're beginning on those intervals and how they're ending on the intervals or no end. So what could this look like? Well, from negative 4 to 1. Something, I have to have a point someplace here that's filled in to start. And at 1, it's going to have to be open. Okay, so I have my dashed line. And something in this section's got to decrease. So I need something that's starting up higher and going lower. And don't forget, we have that at 0, negative 7 y-intercept. So it's got to go through this point here. So high, somehow decreasing down through this part, open circle, because it's not included, right? And then we need something constant when x is greater than 6. So greater than 6 would be here, and it's going to go to infinity, right? So in this section here, I need something constant, but we're not using that input. So constant means no change, something horizontal, continuing on. So if we compare our graphs, let's see how they're similar to each other. Now think about what we said. Something has to have a definite beginning at -4, which I have. I have a point here, right? Filled in definite beginning. We said it had to decrease and go through 0, -7, so I have it doing just that. And ending here at 1, but not being included. Then, again, we said starting here at 6, but not included. I have an open point, and it's constant. Now, this piece could move anywhere along my graph. It doesn't have to necessarily be up in this section here. Let me group it so I can move it. I could have it anywhere, right, along here, just as long as it's got that starting point at 6 but not being included, no change in the outputs, continuing to infinity. So today we did a lot of work with increasing and decreasing constant intervals, writing them in interval notation and equality notation. We also talked about some key features with x-intercepts and y-intercepts. We did talk about turning points. We're going to look at more of those as we go forward and see if we can classify those turning points as either being maximums or minimums, more that we learn about our functions. So it's going to be your turn to practice these features, and we'll see how those go.